YouTube, one touch upload.
Okay, so these four are acid: HCl, HNO3, H2SO4, and H6GCOH. This is called the only weak acid you learn. Okay?
Weak acid.
The rest are all strong acid.
Weak acid.
Yeah, what is strong, what's weaker? In the
weak acid is like strong acid diluted.
No, not really. They're not talking about how much it dilute or concentrated. Somehow, if you have concentrated H2SO4, right, we call it a weak acid. It's a dilute H2SO4, we call it a strong acid. Okay? We'll talk about those things in acid.
Let me see, H3COH is very corrosive.
Not really. I told you corrosiveness nothing to do with acid.
It's very
it depends on whether it is a dehydrating agent. And it never says that when it is a concentrated acid, you can be a dehydrating agent. No, not really. Concentrated, HCl like our stomach, concentrated, but not dehydrating. Okay? Not so dehydrating, not that corrosive. Okay, so you need to know what is acid. Okay. So what is metal? What do you know about metal? You got to remember metal with 3 series. If I ask you to remember, potassium, sodium. Have I asked you to remember?
No.
Okay, potassium, sodium, calcium, magnesium, aluminium. Okay, zinc, iron, tin, lead. They're in order. Okay, hydrogen, copper, mercury, silver, gold.
Copper, mercury, silver, gold.
And if you bother platinum. Okay, this is the metal reactivity series. Okay.
Serious?
Metal reactivity series. Okay, that means how reactive they are, the metal. This is very reactive all the way to very unreactive. Okay.
Must remember.
You must remember this, okay? Because this is what it is tested there. So, but I can teach you how to remember.
Yeah.
The only thing you need to remember is zinc and tin. Okay, so just remember yourself, zinc and tin, zinc and tin, zinc and tin, zinc and tin. Why is it so? Because
zinc and tin.
Zinc and tin, okay, fine.
Zinc and tin, zinc and tin.
Zinc, iron, tin, lead. Okay, don't try to remember until you can't remember what you're talking about. Okay.
Zinc and
so
tin,
take all of our periodic tables. Okay. Internationally, all the secondary school standard. Okay. That means they first learn chemistry, right? They will not try to touch the transition elements. Okay. So by sweeping the proton number, keep going, right? When can you hit your first transition elements?
Sweeping the proton number.
Proton number, you know what's proton number?
Yes.
It's atomic number.
Yes.
So you keep increasing atomic number going through one another. When is the first instant you hit the first transition elements?
Transition elements.
Yeah, transition elements means that it is not doesn't have any groups. That means not group 2, not group 3. Okay?
Scandium.
Yep, so what's the number?
45.
Give me the atomic number, please.
21.
Yep, 21, right? So if you first hit the transition element at 21, they don't want you to learn 21. They want you to learn until 20. Okay? Just the one big one before that. Okay? So the idea is that they want you to focus on the elements before 21, so it's 1 to 20. These are the 20 elements. Okay, they should focus on when you're on secondary school standard and first learn about chemistry. Okay? Good, okay, so let's come back. So what are the electronic configuration you learn is order 2 all the way until 2882.
Yeah.
2882 is 20, right? Okay, so you will not learn anything after calcium in terms of you will learn a bit but not in detail, okay? In the transition elements and such. Okay? So why the first 5 guy can be remembered is because the first 5 guy is in your 20. Okay? And they're all metals. Okay? They're actually all the metals in your first 20 elements. Okay? So how do I know the reactivity series is like that? The idea is that if you have 2 elements on the same column, okay? A and B on the same column, let's say group 1. Which is more reactive?
A.
And why?
A.
Why?
Because it's on top.
Why?
Because they put it on top.
On top so?
So it's more reactive.
Why?
Because they put it on top.
Put on top, that's more reactive. Why?
Because you write on top more reactive.
Why is that? Why on top more reactive?
Because you write on top.
Yeah. So exactly why you? Because you put on top, it will be reactive.
Yeah.
Why?
Because that's that.
What? Who tell you that's that? Under what theory? How come?
No idea.
Oh, so how do you know?
I guess.
By the way, how come this one is on top?
I don't know.
You don't know
No idea.
So why if A is on top, B, what's the meaning of this?
B come after A.
Sorry?
B come after A.
What do you mean come after and come before? They are arranged by what?
By letters.
Not really. I don't think so. The first one is hydrogen. It starts with H.
Oh, you mean periodic table?
Of course, I'm talking periodic table. What else I'm talking about?
Atomic number lah.
By atomic number, right?
Yeah.
So is it about more reactive on top? No.
No.
It's just because the A atomic number is smaller than B. That's why it's on top. Okay. So, which is more reactive? You may not know, right? Okay. Okay. Metal. Okay. So why chemistry?
Huh?
Why chemistry? Yeah. Why chemistry is all about reactions, right? So when metal want to react, what does it want to become?
Gas.
It becomes gas because you're guessing, right? Yeah. Okay. That's a piece of nonsense. So when they want, you're right, man. Maybe you're actually talking something that is right. What gas?
Noble gas.
Good. Yeah, exactly. You're right. Okay? It's not really gas, but noble gas they want to achieve. Okay? You're correct. Okay? How can I say you're wrong? Scary. Okay. So in order for the metal, now metals are all group 1 to group 3. To become noble gas structure, what must he does? What must he do?
Shoot the proton.
Shoot the proton can become noble gas. You sure or not?
Add proton.
Wait. You want to become the noble gas, or would want to have a noble gas structure?
Want to have a noble gas structure.
Want to have noble gas electronic structure, is it? So they want to have the same electronic structure of a noble gas. Do they want to change the proton number?
No.
No. Okay, so don't shoot proton. Okay. So what do you want to do?
Shoot electron.
Shoot electron so that you get more electron, is it?
Yeah.
So the sodium is group 1. It's a 281. You want to become noble gas, you shoot an electron so it becomes 282, is it?
Yeah.
Is it noble gas?
No.
Or shoot one more?
Yeah.
So
No.
shoot it? Oh no, they shoot how many?
Take out.
Or take out one, okay? Wow, now you use a brain. Okay, thank you. Good. All metals want to gain electron, lost electron. After reactions.
Lose.
You will lose electrons, right? So how do you define as more reactive metal? Easier to lose, harder to lose.
Easier to lose, harder to lose.
Easier to lose electron is more reactive, or harder to lose electron is more reactive?
Easier to lose is more reactive.
Easier to is more reactive. So you want the force between the inner nucleus of an atom to the outermost cell's electrons. This attraction force, you want it strong or weak?
Weak.
Weak. Weak means reactive.
So you need more rings.
Right.
And A has more rings than B.
This is a piece of nonsense. What's the meaning of period?
Oh yeah, sorry, wrong. Should be period, not the column. Yeah.
So, which is more reactive?
B.
Why? Reason?
Cause more
Ring.
weaker.
Therefore?
Weaker.
Yeah.
Therefore more
Close the
reactive.
whole story, okay? B is more reactive because it have more ring, electron ring, then because you have more electron ring, then
Weaker bond.
that's too fast.
Weaker attraction.
Why weaker attractions? Why more ring with weaker attractions?
Further.
Yes, that's the key point, okay? Don't miss that one. More ring, further. Further, weaker attractions, right? What attraction is that? Attraction between
Nucleus and electron.
which electrons?
Outermost electron.
Outermost electron, not the rest. You don't care about the rest. The weaker between the nucleus and the outermost cell's electron. Therefore, it is more reactive. Or easier to lose electrons, so therefore, it's more reactive metal. So the idea is that for any two elements, if they are the same group, the below one will be more reactive than the top one. Okay? Now one more factor. If you have a substance A and B in this way, they are on the same period. How about this? Now should they have the same rate?
Yeah, they have the same rate.
So same radius, right?
Yeah.
So what is there any difference?
Yes. B.
B is what?
Because the outermost electron is lesser.
Outermost electron is lesser.
No, A.
A. Because?
Outermost electron is more, so is still weaker than.
So it's more, why is it weaker? Repulsion, is it? You got one more guy to repel you.
So that they spread the force.
So they share the force so that you got lesser force, is it? That's wrong. Okay, now this is Earth, okay? If I'm here, I'm dropping with 9.1, right? The gravity, right?
Oh yeah, it's the same.
If you're here, I'm still dropping with 9.1. Okay, wait. If I want to change from 9.1, more people will I change 9.1? No.
If yes, China will be floating.
Yeah, you're right. You're right. But what must I increase my 9.1? What must I change in order to increase the 9.1?
The Earth's gravity.
You're right. Or maybe the Earth itself I'm gonna change. Change to Jupiter. Wow, I tell you this becomes 16.
I jumped and I died already.
Okay, whatever it is. So the idea is that all these things you need to know. You increase if you don't know effect. But this one does affect. So how about this? Same thing. There is a diff. Not because this change, but because this change. So what is the diff between this and that in terms of things here?
Depends on the nucleus.
Yeah, so what is the difference in this nucleus from this to that?
Bigger and smaller.
Not really. Nucleus size is always very small.
Stronger and weaker.
Stronger and weaker. Or what's the difference between the hop over one guy? What's the difference? The atomic number, what it increased, right? What's the meaning atomic number increased by 1? Number of what increased by 1?
Proton.
So number of proton increased by 1. What happened to the nucleus?
Weaker, because you still need to suck the proton.
Wait. You have 1 proton more. What happened to the positiveness and negativeness of your nucleus?
Still positive.
So if you got 1 proton more, will be more positive.
No.
The reason?
Because the proton is negative.
Proton is negative.
Proton is positive, man.
Wow, oh no, I'm going to say something which is more fundamental. Proton is positive. Electron is negative. Neutron is no charge. Okay? Proton is exactly 1 positive, the same as
so the nucleus will be more positive.
It will be more positive. So when you have more positive, the force is stronger or weaker? Stronger, right? Stronger means less reactive, right? So it still be more reactive than A. The reason is because
there's more proton.
B has lesser proton. So the nucleus is less positively charged. Okay, with the distance more or less the same, the force is weaker. When the force is weaker, more reactive. Okay?
Yeah.
So the idea is that you want to be very reactive, go down to the group and go left to the group. Okay? Go down and go left. So which factor is higher?
Factor.
Well, yeah. If I have 1 shift by right, 1 shift by down, so the increased amount or the decreased amount, which is more important? Okay.
I, number 1.
Yeah, this is more important. Okay. Up, down first, then left, right. Okay. So, among the first 20 elements.
Yeah.
For periodic table, which is the most reactive metal?
Which is the most reactive metal?
Yep, for the first 20, before you hit the scandium.
Potassium. Yeah, for JC.
So what's next?
Next, calcium.
You sure?
Okay.
Which factor is stronger?
Oh, up down. Sodium. Sodium then lithium. Then calcium.
Yep, calcium.
How?
Because we just don't talk lithium. We don't talk about the second period in the metal series. You're right, lithium. Okay, if I got to chuck lithium in, lithium got to be a third. Okay? But the period 2, right, we don't talk.
Calcium, then magnesium, then aluminium.
Yeah, so this is why potassium, sodium, calcium, magnesium, aluminium, just like that.
Then zinc eh?
This is why
zinc is after 20.
This is why I asked you to remember this 4. Zinc and tin lead. Right? So the first 5 you read from periodic table. And the next 5, next 4 you will remember is zinc and tin and zinc and tin and zinc and tin. Okay, mumble yourself to zinc and tin.
Zinc anti-lead.
Okay, zinc and tin lead. Okay.
Zinc is my friend's name.
Zinc, iron, tin, and lead. Okay.
Anti-zinc lead.
Zinc anti lead. Anti-zinc lead. Okay. Zinc anti lead.
Zinc is my friend's name.
Okay, whatever. Okay. So remember
Anti-zinc
anti lead. After zinc and tin lead, right, you have hydrogen, okay, which is not a metal, but chuck it there, okay. It's to help you for some reactions. Okay. Hydrogen. After the hydrogens, okay, everything is about money. Okay. Yep. Money, okay.
About money means what?
About money, okay. Copper, mercury, silver, gold. They're all according to their price.
Oh. So it's not weaker or stronger lah. It's according to price lah.
According to price, actually it's because stronger also. Okay, so copper is more relative than mercury, more relative than silver, more relative. Why?
Because it's more expensive.
Why is it expensive? Because it will not change. It will not change why? Because it's stable. The more stable, the more valuable it is. Okay.
Then why more
reactive, right? Normally it will be oxidized.
Why more reactive? Why more reactive?
Say again?
Now why more reactive the A?
Which one?
The number 1 one. Period 1, period 2 and first column. You did not say why is it more reactive that one.
Which one?
The period 1, period 2.
This one? This one?
No, yeah, the other one.
This one?
Yes.
This one because of the distance.
Further away.
Further away weaker the force. This because of nucleus number increase. For the same
Weaker is more reactive.
Yeah.
Reactive because the distance from the nucleus to the outermost layer electron is further. Oh, so you cannot see a atom one.
Cannot see the atom one. You are seeing an atom actually.
Huh?
What are you talking about?
Cannot see atom ah.
What do you mean I cannot see atom?
That means you cannot see a atom ah.
Cannot see an atom, is it? I think so, yeah. Atom is too small.
I thought can. Last time I thought can.
They have the I think quite a few years ago they can do it already. Now sorry, cannot, okay. Cannot. It's in the electron level. Still very problematic.
Then what's smaller than electron? Electron must be created by something, right?
Now, how come we can't see things, right? You got to first ask yourself what's the meaning by seeing things. If you see anything, it doesn't mean it's there. Okay, what you see is image. Okay, something you see you can't touch. Very general. Fire, a flame. Flame, you see that it is a thing there, but you can never get it.
Yeah, but
so is it really?
You burn your hand, right?
But assume that you wear a glove, okay, but you still can't grab anything as if you see the shape. Can? So sometimes something you see, right, is not. If you see this shape, it doesn't mean they have a shape that you can touch. On the other hand, something you can touch may not be able to see also. Okay, so.
Like wind.
You're right. Okay. So So when you go to the atom level, right? So what is the actual things in the atom that contribute mass is something solid. Okay, that may even it's not empty space. It's the nucleus. Okay, so if you want to see something which is very solid, deflect light and all these things, right? Light shining will not pass through. That means it's not empty space, right? It's the nucleus. Size of atom is already small. Size of atoms compared to the nucleus is a soccer field size to a soccer ball.
Yeah.
So even smaller than dot. So a lot of things about atom is empty space, and you got to include them as an atom because the electron are floating inside there. Okay, so I don't know what you want to see. Okay, I don't know if you can see anything. See the nucleus. Okay.
Yeah, what is inside the nucleus?
Inside the nucleus is proton and neutron.
Then what is inside the proton and the neutron?
Quarks.
Then what's inside that?
Sorry?
What's inside the quarks?
Energy ray.
Then what's inside the energy ray?
Energy ray, there's no more inside ray because they're already electromagnetic.
What is quarks?
Wiki quarks. Okay.
Even smaller than electron.
Quark is the things that make up all the matters. Okay, but actually in quarks level behind the 1997, actually quite old already. The energy ray theory already proposed it. So they explain that everything is actually in the form of wave, light wave, like electromagnetic wave. So it is the wave that as if it's a matter, that kind of things.
Proven?
Proven? Not really proven, proposition, and it makes sense. Yeah. Nothing can prove that kind of things lah.
Only makes sense only not proven lah.
Einstein's theory about relativity till today is still not proven.
Relativity.
Yeah, but we're using
using
all the space science are using it.
猪八戒的相对论.
And what is that? Your handphone, last time the handphone bling 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 those kind of light. Remember?
Huh?
Those handphone antenna last time are being wear one. They changed the antenna to something when call comes in, bling 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 then bling, right?
I don't remember. I don't know.
Do you see some sticker that can just blink without putting a battery there? Also never see.
Sticker. Oh yeah, yeah.
Yeah. So
like,
without battery,
like the neon.
yeah. Without battery, how come it can blink? How come there's light come out?
Fireflies.
Not really. It's due to the law of from Einstein law of photoelectricity. Okay, photoelectrons.
But it's also not proven.
They're all proposition. You can't prove it.
It's true, but it's not proven lah.
Yeah, there's propositions. Yeah.
Maybe alien can
Sorry?
Maybe
we're using it. If that doesn't hold, you can't have this product.
I say maybe alien can.
Maybe when we can travel in spirit light, we can do that. Okay.
B the B is more.
So all this thing.
Period one is no. Column one is stronger than column more reactive than column B because there's less proton.
Less proton, yeah. Okay. Okay, so this is what's the objective here? To help you remember the relativity series. Okay, good.
Why?
So after the you met.
Because more proton, the nucleus is more positively charged, right?
Yeah, so the force is stronger, so the electron is harder to lose. Okay, so now you know. Now, why do you need to know the metal relativity series? Is that the reaction one, right? As with metal, if you salt and hydrogen, has a limitations. This is only for all metals above hydrogens.
Charged. More positively charged then. More positively charged than what? Then it's.
Can you think about? Don't ask. Think. It's common sense, right? More positive charge what happens to the electrons and this and that.
So it's stronger lah.
Yeah, stronger. So it's a more reactive, less reactive.
So the force is stronger.
Hey, time's up. I gotta go.
Yeah, I also gotta go.
Can't do anything. Okay, good.
Energy ray. You think got alien?
How do you define alien?
As in you think got alien or not?
What do you mean by your alien?
It's not from this earth.
Not from this earth?
Yeah.
What? So other than not from this, there are many things not from this earth. Yeah.
Like human lah, they can survive.
Like human ah. How do you define like human ah? Like human, I think there is hard to believe leh.